Hello everyone, as you know I am Paul, your e-hobby guy, and in today's video we will be looking at an emergency notification system. Using analog electronics, we will be using a few basic components, designing a circuit, we will breadboard it, test it, and then build it to do an actual emergency test simulation. I will go through everything in detail, so let's jump right in. Sketching something up here, I'm just going to say we're going to have a DC voltage supply here. The emergency switch we'll put up here, and we'll just say it's normally open for now. Now I'm going to want audible and visible notification, and so switch is here, audible and visible notification is somewhere else where somebody is going to be, let's say, all the time, 24 hours. So let's put a buzzer as an audible notification, so I'm just going to put a buzzer. Now what I'm going to do is just put a normally closed switch in front of the buzzer. Buzzer can become annoying pretty quickly, and I always like to put an off button just as a temporary measure to ensure that we can shut it off if we like. So let's just put a buzzer here, and now we have a buzzer, but I want visible notification as well. So if we do connect this DC voltage up to the emergency switch, let me label this emergency right here. This switch is taking the positive, and we'll take this positive and bring it right down to this buzzer. So very simply at this point, if this switch closes, it brings down here and sets this buzzer into its on position, making noise. Now this would be a very simple situation. Now what I would like also is to have visual notification. So I'm going to put an LED, current limiting resistor, first. Then we'll just put an LED here. Now what we've added is, someone hits this switch, we've got the buzzer, it's going to sound, and the LED is going to light. If someone does decide to temporarily silence this buzzer, we're still going to have the LED on as a visual notification something is wrong. What if we want it in more than one location, perhaps several locations? So let's see if we can add in a second location and bring it down further. So I'm just going to draw the same configuration. Right here's a buzzer, and again, normally closed switch. Upon closing this, we'll just tap into this when it does come down and bring down here. So right now from this switch we can bring down, it's going to set this buzzer off. If this is silenced, we still get power down to this lower buzzer, and they have an opportunity to silence it also. And we'll take this same resistor and LED configuration and add it here as well, so that we're just duplicating this notification setup in another place, and we can bring this all back up to the negative. This is tied in here, and we could do this over and over again as long as we have enough power from our source to power up the buzzers and the LEDs along with the current limiting resistors. For now, I'll just say we're going to do 2 for simplification, and we'll see if we can breadboard this to make it happen. Today I'm going to work with a 24 volt DC voltage, and I'm doing this specifically because I happen to have an emergency call button here. And this happens to have some circuitry that lights up this LED, and it's requiring 24 volts in. We'll get this and use this, see if we can get this situation set up. We'll do one first, make sure we prove out the concept, and then we'll add this second station so that we hear both of them going off. We'll bypass both, just check the whole functionality of the whole thing and see if we can get this up and working and create a circuit that can really be possibly life-saving for somebody that we may want to help, and use simple electronics to make it happen, to keep a monitor on them, make sure everybody's nice and safe and sound. Before we go to the breadboard though, there's only one thing we have to figure out, and that's the value of the resistor. Looking at a typical LED, we'll make sure it's red, because red is danger. Red LED, we want 20-25 milliamps. I'll say 20 milliamps. My voltage is 24 volts DC, so we know V is equal to IR. The resistor, R, is going to be equal to V divided by I. The resistor we want to choose is going to equal 24 divided by the current, 0.02. 24 divided by 0.02. So we're looking for 1200 ohms. Let's see what I have. And so looking at this range of resistors that I have, I can see right here I do have 1200 ohm resistors, 1.2K of course. Right now, to get ready, I'll just pull 2 of these out. Now we should be ready to move on. Here I have some of my switches. looking over here, I have some simple Form A on-off switches. I think I'll use 2 of these. I can't mount these in breadboards, but we'll put some wires on these and make them fully functional. Okay, here out of my buzzer collection here, I have 2 12-volt buzzers, which we can use. Let's put those to the side. I need to know the amount of current that's flowing through each of these buzzers. Let's just measure the current flowing through. So I have my power supply is set 12 volt, and it's running through my meter here. Let's set this buzzer. So we can see that this is taking 23, we'll say 24 millivolts to run this one buzzer. So we know that 24 milliamps for one buzzer. I'm going to have 2 buzzers. We'll multiply that by 2. I'm going to have 2 LEDs. So we're going to add the current for 2 LEDs, and we know that's going to be 20 milliamps, 0.02 amps times 2 LEDs. Let's figure out what this total current is going to be for the 2 buzzers and the 2 LEDs. 2 times 0.024 is 0.048, plus 2 times 0.02 is 0.04. Adding these together, 0.088 amps. So 88 milliamps is going to be the total current taken by the 2 buzzers and the 2 LEDs. Coming back up here, instead of 24 volts DC, I'm going to make this 12 volts. So now this is 12 volts. We'll redo our calculation here, and we'll put 12 up here. 12 divided by 0.02, 600 ohms. So I'm going to put these 2 resistors back, and I'm going to choose 600 ohms instead of 1200 ohms. So looking at this range of resistors here, I have 560 ohm resistors and 680. 560 is close enough for me, so we'll pull out 2 of these. And now you can see the evolution as I'm developing this circuit of how a circuit design is going to change and evolve such that it conforms to the things that we have on hand. Everything is going to be operating now at 12 volts and not 24. So very simply here, I connected 2 wires here to this switch. So we're going from the positive rail here, this red wire, through the switch into the positive of the 12 volt buzzer. Coming out of the negative of the buzzer is going right here to the negative rail. Here I have the resistor. Anode is connected to the positive, and the resistor is going to the cathode. Cathode is going to the negative rail right here. So I have the negative of my power supply hooked up here. I have 12 volts on my benchtop power supply. We'll see what happens. We should get the buzzer going and the LED coming on. Yes, that's exactly what happened. Here's the bypass switch. So the bypass switch works. The red LED is lit right here. Let's wire up a second set of these and make sure we can do the exact same thing. And we'll measure the current draw at that time of the entire circuit at 12 volts. So here I have 2 set up. One buzzer here with its LED, second buzzer here with its LED. I just moved these a little closer to each other to make room for these. I'm going to apply this 12 volts. I should get both LEDs and both buzzers buzzing at the same time. Let's give it a try. Well, it looks like both LEDs lit. I must have both buzzers bypassed. So let's give one buzzer switch. That's one buzzer. And let's go to the second one. Second buzzer. Both buzzers working. What I'm going to do now is just check the total current draw to see if it compares with what we calculated earlier. Let's get the meter hooked up and we'll see what it looks like. We'll look at the milliamps when no buzzers are on, when one buzzer is on, and when 2 buzzers are on. Basically that's the max current that this is going to draw. Let's see what it looks like. Here we are hooked up with 2 LEDs on. It's not 2. There we go. You can see the LEDs are on. And we can see we calculated for approximately 20 milliamps for each LED. And we are in fact 38, very close to what we calculated. So that's very good. These are going to have a long life. So now one by one, and it might get noisy here like I said, so I'll turn this buzzer on, we'll look at the current, and I'll turn this buzzer on and we'll look at the current to see if it comes close to what we did calculate, what was going to be required for this circuit. So first buzzer turned on, yes. So we jumped up to 61 milliamps adding in this one buzzer. Let's jump and turn on this second buzzer. Both buzzers are on. 84.3. Let's silence. 84.3 milliamps. We calculated approximately 88. As we know, there are tolerances in everything, including resistors. 84.3, we'll say 84 to 85 milliamps is what this is drawing.
Here I am connecting the two 12-volt power supplies in series with each other.
Okay, so here I have both of these tied in series, positive to negative. If we plug both of these in, we should get 24 volts across here and here, 12 volts from here to here, and 12 volts from here to here. So 12 added comes to 24. I'm going to protect this with a little tape. We'll plug them both in. We'll measure to make sure that happened, and then we'll continue. We should have 24 across negative to positive. There we go, 24 and a half. That's perfect. To the center tap, both should have 12. Yes, 12.26. And then we'll go negative to the middle, 12.23. That's certainly acceptable. It's exactly what we need. I'll make jumpers to go from here to the breadboard, and we'll take it from there. I'm going to hook the negative up, get that onto the negative rail on the breadboard, and the positive here into the positive on the breadboard. Hey, and we still were in this state. As we can see, the two LEDs are lit. Let's see. One buzzer on, two buzzers on. Absolutely no power problems at all. This is getting 24 volts. This is getting 12. We'll just go through a full functional test here. So I'll just pull this down. And you can see it's working perfectly. Silence. Silence number 2. Now let's see if we can put this into a real practical, real world use. Here I have two blank single gang wall plates. I could easily mount an LED here, a buzzer, and a bypass switch for each set so that we could interconnect and mount these in a wall in locations other than where this might be, where the person in distress might be. And then we can interconnect the three with wires and the power supply. So let's get an LED, buzzer, and bypass switch mounted onto each of these wall plates.
Here I am just using some masking tape so that I can mark out the position of the three holes for the LED, the buzzer, and the switch. And then of course I drill the appropriate holes, 1/8 of an inch, 1/8 of an inch, and 1/4 of an inch for the switch. And now it's time to mount the components, and so I just placed them in the holes and just use hot glue to hold them in place until all 6 components were firmly mounted.
We've got the LED, buzzer, and the bypass switch on both. Over here I have the 12 and 24 volt, the center tap 12 here, 24 volt here, two negatives jumping everything together per the schematic. So now I will go through a full simulation. Let me kill the lights here a little bit. Just to show the LEDs, we can see this red lamp right here. These are the two LEDs. I'll pull this down. We're in full alarm. Both LEDs are on here. Bypass, bypass, unbypass, unbypass, reset. This is a real life application of using some simple analog electronics to make a potentially life-saving device notifying people in remote locations. These can be mounted anywhere as long as you can get a wire from here to here per the schematic, using this as an emergency notification device. For those in the outpost stations, they can be bypassed, as I said before, to silence it while you go and check out the emergency situation. Be sure, as always, to hit into the unbypassed position. As always, I really do appreciate you taking the time to watch. I hope this spurred some ideas in your head about things that you can do to help possibly those that might be alone and in danger, or those that may be in other rooms that may not be able to notify you. You don't even need a fancy switch like this. It could be any switch that can be used, a pull cord, anything that can be used to flip a switch, throwing power over into the buzzers and the LEDs to somewhere someone may be in a position to run and help in case of emergency. Thank you again for taking the time to watch. I really do appreciate it. I hope you learned something. Take the time right now to click that subscribe button. Follow me on social media. I'll see you next time.